Welcome to this lesson on ratio problems. Please be sure you have these notes in front of you so we can begin our lesson. Our learning objective for today says I can use ratio reasoning to solve problems. So before we start, let's remember that ratios compare two quantities. So for example, you can compare dogs and cats, and you can compare gummy bears and chocolate bars. Those are two different types of quantities. So using the part-to-part ratio above, for the pancake recipe, it says that we have 2 eggs for every 3 cups of flour. I can write that ratio 3 different ways as 2 over 3, 2 colon 3, and 2, 2, 3. And once again, that's a part-to-part ratio because eggs and flour are two separate items. So I'm going to draw a part-to-part ratio like this. Eggs will have 2 boxes on top, and flour will have 3 boxes on the bottom. I can also use a table to describe this information. I can write 2 eggs and 3 cups of flour to have a total of 5 total items. I can scale up, so if I multiply everything by 2, 2 times 2 would be 4, 3 times 2 will be 6, and the total amount of items, 5 times 2, will get me 10. The last thing we have is something called proportions. A proportion just says 2 fractions are equal. So if I have the fraction eggs over flour, it should equal eggs over flour. Those are 2 equal statements. So one statement I can say is 2 eggs over 3 cups of flour is the same as 4 eggs over 6 cups of flour. So these are 3 different ways to solve part-to-part ratio problems. Another thing I like to talk about is something called a part-to-total ratio. And you can find someplace in your notes in your handout to go ahead and write this down. An example of a part-to-total ratio would be 3 gummy bears for every 5 pieces of candy. So a tape diagram for this would look like 5 pieces of candy like this. That's divided up. And I would color 3 of them. And these 3 are considered the gummy bears. Another thing I can use as well is a table. So if I'm giving this table, I can write gummy bears as one part, and I can write total as the bottom part of my table. Remember, as a part-to-part table, you don't need the middle row. And if I fill this out, if I have 3 gummy bears, I have a total of 5 pieces of candy. I can scale up by multiplying that by 2, so I would have 6 gummy bears, and scale up the total by multiplying that by 2 as well, and I can get 10 pieces of total candy. I can also create a proportion by writing 2 fractions. I can write gummy bears over total, which should equal gummy bears over total. So for example, if I have 3 gummy bears over 5 total candies, that's the same as 6 gummy bears over 10 total candies. Because if I reduce 6 over 10, I still get 3 over 5. So these are 3 different ways to solve part-to-total ratio problems. So let's go ahead and use these key concepts to solve the following examples. So for example 1, it says Heritage Middle School has 150 students. 2 out of the 3 students in Mrs. Mason's class prefer gel toothpaste. Use this ratio to predict how many students in the entire middle school prefer gel toothpaste. So when we look at this problem, let's take a look at the key information. They're giving us 2 out of 3 students in the class prefer gel toothpaste. I can think of this ratio as a part-to-total ratio because the students who like gel toothpaste are still students. So I can write it like this. 2 over 3 students. I can write my part to total ratio as 2 colon 3, and I can write my part to total ratio as 2, 2, 3. So since this is a part to total ratio, what I want to do is I want to create a part to total diagram. So I'm going to draw my part to total diagram like this. A total of 3 boxes, because that's the total amount. And I'm going to call 2 of them gel toothpaste. So these 2 are gel toothpaste. The empty box could be the students that don't like gel toothpaste. When you read the problem, it says that the total amount of students at the school is 150 students. So if I look at my tape diagram, I know that I have a total amount of 3 diagrams, or 3 bars. If I group all of this, I can call all of that 150 students, because that's the total amount of students. And the 3 boxes represent the total amount of students. So what I want to do now is I want to take a look at the total amount, which is 150, and I can divide that by 3 because there are 3 boxes. So 3 divided by 150, after computing the math, I get 50. So each box represents 50. So this represents 50, this represents 50, and this represents 50. So it says, use this ratio to predict how many students in the entire school prefer gel toothpaste. Well, the students that prefer gel toothpaste are the amount in the blue region. So 50 plus 50 equals 100. So 100 students prefer gel toothpaste. Now you can solve this same problem using a table or proportions and you'll get the same answer. So pause the video and complete this Got It problem, and we will discuss the answers in class tomorrow. So let's talk about example 2. It says the ratio of the number of text messages sent by Lucas to the number of text messages sent by his sister is 3 to 4. Lucas sent 18 text messages. How many text messages did his sister send? So what we want to do is we want to identify what type of ratio this is. We know that this is a part to part ratio because we're comparing 2 different people. We're comparing Lucas and we're comparing his sister. So I can write my ratio as 3 over 4. You can write it as 3 colon 4 or 3 to 4 because you're comparing Lucas to his sister. So since I'm using a part-to-part ratio, I'm going to have to draw my diagram. So for Lucas, it says Lucas sends 3 text messages. So I'm going to draw a part-to-part ratio using this diagram. So here's 1, there's 2, there's 3. Lucas has 3 boxes. Right underneath it, I'm going to draw his sister's boxes, which is 1 box, 2 box, 3 box, 4 boxes. So that is the diagram that represents the part-to-part ratio for this problem. Now if you read the problem, it says that Lucas sent 18 text messages. The problem says Lucas sent the 18 text messages. So I want to put my grouping symbol right above Lucas's diagram, and I'm going to place an 18 right above that. And the reason why I did that again is because the problem said Lucas sent 18 text messages. I'm going to take the 18 and divide that by 3 because there are 3 boxes. So after doing 18 divided by 3, I get 6. So each box is worth 6, 6, and 6. So if the top boxes are worth 6, the bottom boxes also have to be worth 6. Now the problem is asking me this. How many text messages did his sister send? Well, his sister sent 6 plus 6 plus 6 plus 6, or you can say 6 times 4, which is 24 text messages. So Lucas's sister sent 24 text messages. Once again, you can solve the same exact problem using a table or proportions, and you will get the same exact answer. So let's talk about example 3. Example 3 says a survey found out that 12 out of every 15 people in the United States prefer eating at a restaurant over cooking at home. If 400 people select eating at a restaurant on a survey, how many people took the survey? I can tell that this is a part to total ratio because I'm comparing 12 people out of a total of 15 people. So the 12 people that prefer eating at a restaurant are still people. So I'm going to write my ratio as this: restaurants over total. I know that for every 12 people who prefer eating at a restaurant, 15 people took the survey. I can reduce that by dividing the top and bottom by 3, and I can get 4 over 5, or 4:5, or 4:5. So you always want to make sure you reduce your ratios, because when you draw your tape diagrams, you want to draw the least amount of boxes as possible. So since I know that this is a part to total ratio, I'm going to go ahead and draw one large box and divide that into 5 sections, because that was the total amount in my reduced fraction. Then I'm going to go ahead and label or color 4 of them, because 4 out of the 5 represented people who selected that their preference was eating at a restaurant. So I'm going to go ahead and group these 4 and call it restaurant. So when I read the problem, it says 400 people selected eating at a restaurant. So I know that the blue region is worth 400 because 400 people selected eating at a restaurant. So if I take 400 and I divide that by 4, because there are 4 boxes, I know that each box is worth 100, because 400 divided by 4 is 100. If each box is worth 100, then the last box is also worth 100. So the boxes that are shaded blue represent the people who prefer eating at a restaurant, and the empty box represents the people who prefer cooking at home. So the tape diagram says 400 people preferred eating at a restaurant and 100 people prefer cooking at home. I can respond to the question of how many people took the survey by looking at my tape diagram. I'm going to add 100 plus 100 plus 100 plus 100 plus 100, and I'm doing that 5 times because there are 5 boxes worth 100. So when I add it up, I know that 500 people took the survey. Now I can solve this problem using a table or proportions, and I would still get the same exact answer. So go ahead and pause the video and complete these Got It problems, and then we will discuss the answers in class tomorrow. Notice there are 2 Got It problems here. Here's Got It problem B and Got It problem C. So now that we've completed the lesson, go ahead and self-rate yourself and let us know how you feel. If there's any part of this video that you do not understand, please go back and watch it again, or come to class with some questions so we can discuss it in further detail.